Hello and welcome to the 6th installment of Grammar Development with LFG and XLE. As usual, I'll recap what we did last time. We integrated OT marks, optimality theory marks, into the grammar, and we did that mainly to deal with ambiguity, to constrain ambiguity in the parsing direction, but also a little bit in the generation direction. We looked at that a little bit. And you should have implemented pronouns as part of your exercise, as part of your practical work. This time we will look at imperatives. Imperatives are interesting because, or I chose imperatives because they allow me to illustrate the use of empty nodes to you, something that's quite useful for grammar engineering. As part of that, I will also talk a little bit about the notion of constructions in LFG XLE. Secondly, we'll look at coordination. Coordination involves quite a bit of grammar engineering, but once you've got it in there, it's a very satisfying part of the grammar to have. With coordination, we will introduce regular expression macros as well as meta-rule macros, which are statements that hold for the entire grammar. With coordination, we'll be getting into more high-level grammar engineering. On the one hand, it's all basic parts of XLE that I'm telling you about. On the other hand, they are quite complex constructs, complex notions that you have to be able to absorb. And you will be doing much more grammar debugging in trying to get all of this to work. And you should have been doing a lot of grammar debugging already. When I go through and show you the grammar this time, I will try to illustrate some of the debugging methods or some of the common errors that happen. So we'll do that together this time, in a sense. And third, we will be looking at proper names. That is, I won't look at this with you. This will be part of your practical exercise. You should do that and follow what we did last time for pronouns. So follow the same techniques and then implement proper names on your own. Okay, so let's start with imperatives. Imperatives are an example of a sentence with a non-overt argument. Languages generally allow arguments to be non-overt. For example, as I just said, in the imperative, the addressee subject is usually omitted. So you can say things like, eat this apple, and then it's not clear who's being addressed. The subject is being left out. Okay, so who's supposed to be the apple? We don't know. You, either you as a person, you plural, somebody is supposed to be eating this apple. Languages also allow arguments to be omitted in other situations. This phenomenon is known as pro-drop in the linguistic literature. There's a huge literature around this. Several of the pargram grammars have implemented pro-drop. So Japanese and Urdu, they allow any argument to be dropped. This is a challenge for grammar engineering, but it is a challenge that has been dealt with. The problem is that once you allow empty arguments to happen, the grammar gives rise to massive ambiguities, and then you have to go around and constrain them. But it's non-trivial, but it is possible. And the Japanese grammar, which was built by Fuji Xerox, is quite large, and it managed to do that quite well. Okay, so how do you deal with null arguments? LFG, in principle, does not posit empty categories. However, XLE does allow for an empty category node E. And this is what I'll be showing you how to use this time. It is a very handy grammar engineering device. If you have functional information that you need to place somewhere, you need to place functional annotation somewhere in the C structure tree, but you don't have a good node to put it on. It's a very, very handy solution for these kinds of situations. You posit an empty node, you annotate that empty node with the functional information that you need, and then it'll just be calculated into the entire F structure. Okay, so here the null argument in imperatives, something like take the exam. You have a verb, take, you have the exam, which is the object, but you don't really have anywhere good to place the information that there is a null subject there. Okay, so how do we deal with these kinds of things? You can complicate your grammar in many different ways. After considering several different ways, the general pargram strategy has evolved to be to introduce a separate category simp, So we allow for different kinds of sentences, one of them simp, standing for S imperative. And then within simp, we posit an empty category that has the information about the subject. This is by far the easiest way to go about it. You can do it in different ways. The solutions tend to be more complicated. So I've given you an example rule for the imperative here. So simp, imperative sentence, goes to an empty category, E, and the function annotation there is subject, pred pro, and subject person is equal to 2. We don't know about singular or plural. Take the exam, I could be addressing just a single person, or I could be addressing an entire class of people or entire groups of people. Okay, so I don't know whether it's singular or plural, but I do know that it is second person. So that's what I've put in here. The excl there stands for exclamation mark and integrates this punctuation mark into the grammar. And as you can see, I've not made it optional like we've done with the period, with a full stop. You could decide, you could have a different design decision. For here, for now, I've said, okay, imperatives will always need an exclamation mark. That's how we can figure out that they're also imperatives. Okay, so the E node, the empty node, does not actually show up in the C structure, and we'll see an example of this as we're going through. So what we'll see in the C structure is a top node simp, and that'll expand into a VP and the excl. We will not see the E node. That's an invisible node as far as the C structure is concerned, an empty node. Okay, that's why it's handy. You can use this. It won't show up in the representation, but you can have function information flowing through it. Okay, so now, so far we've only had S to be the top category in the grammar. But as I've already said, languages tend to contain several different types of sentences. You have declaratives, that's what we've been working with mainly so far, imperatives, questions, and other types. The solution that we've adopted in Pargram, like I said, is to have, have S for declaratives, simp for imperatives, sint for interrogatives, for example. And all of those are expanded into from a root category root. Okay, so what we will do now in the grammar, we will change the root category in the configuration file to be root rather than S. And then root can expand to the different sentence types. So an simp, or an sint for declaratives, interrogatives, declaratives, imperatives, interrogatives. Okay, and I'll show you how this works in the grammar in a minute. As a side note, in a sense, this approach implements the idea of constructions. Constructions have, in the theoretical linguistic world, there's quite a debate around them. And in particular, there's something called construction grammar, which puts constructions at the center of theorizing about linguistic phenomena. LFG, or XLE, our approach here, instantiates constructions. So we have a construction that is an imperative sentence, we have a construction that is an interrogative sentence, but they don't have any theoretical status. They're a grammar engineering device so far. Okay, and they're an engineering solution developed within XLE. Something we have found to be quite practical, but which we have not given a theoretical status. Okay. An alternative solution, as I said, there are alternative solutions. You could just have a single S or CP or IP, depending on what your theory about structures is. And these different S, so you would have a single S, and then in order to say, okay, we have interrogatives or imperatives or whatever, you would then annotate, you would have lots of disjunctions within that S rule, and you would have lots of different function annotations. This is possible, it's absolutely possible, but it's less elegant than the solution we have here. It is also less efficient than the solution what we have here, because as you're writing your grammars, as you're doing grammar engineering, what you should keep in mind is that C structure is implemented via a context-free backbone. Okay, so what you're doing is you're writing context-free rules, you're using a context-free backbone. It's very, very cheap computationally. It's very well understood, it's very, very cheap. The F structure, in contrast, is context sensitive. Okay, so if you are familiar with the Chomsky hierarchy, this is much more complex. It involves constraint checking and feature unification. It is computationally expensive in comparison to C structure. So if you can make C structure do more of the work, then that is generally a better option than having everything be done via F structures. So that's just a grammar engineering type of strategy you should bear in mind with everything that you do. Okay, so now we will move on to the demo of how imperatives could work. And I've put imperative in brackets because what I will I've put implement in brackets because what I will do with you now is I will look through the grammar. There's been some changes compared to what you've seen before. We'll look through this grammar. I'll tell you what the changes are. And then we will implement, I will implement the imperative on the fly. I hope I won't make too many mistakes. Well, actually, I'm planning to make mistakes so that you can see some of the grammar debugging strategies you might have or things that might happen. Okay, so let's look at that. So let's get rid of this and call up grammar 5. So, and let's make this bigger again. 18. Okay, so we can see that. So now let's have a look at what we have changed here. So the first thing that has been changed is that there's a root category root. There used to be S up here if you look back at grammar 4. So that's been changed. Then the second thing that has been changed is files. I actually have a file name here. This file name is commontemplates.lfg. I've integrated this file name not for the imperative, but for the coordination. Common Templates LFG is a file that is part of the starter grammar. You can download it from there. And it has a lot of useful templates that we have found to be, that we have used within Pargram. We found those to be useful within Pargram. So what we've done is we've collected those up into this file, commontemplates.lfg, and you can use them. And in particular, we need to use some of the templates in there to do coordination later on. One could copy and paste from this file. I found the easiest thing to do is to just put this file in. The Common Templates file has a heading. We can look at it. It has a heading in there that, so it's not enough to just put the file name in, right? What you also have to do is you have to say, okay, I'm going to put in all these templates, and there's a heading there. It's called Standard Common. So what I have to do in order for the grammar to integrate these templates is to add it in over here. And that's what I've done here. So the next entries stay the same, but under templates, I've added in Standard Common. Okay, and that means that now the grammar knows, in addition to the demo English templates, I've called them this in my grammar, it will also read in templates from a different place. That's the common templates.lfg, and this is called Standard Common. Okay, up here. So that's what I'll call up. All right, now I won't look at them in any detail. Let's see what else has changed. Rules is the same, morphology is the same. What I've also added to is the optimality order, the gen optimality order. There's been some, this gen bad punct is used with the coordination rules. I've already added that in here. And then here I've added a preference mark so that you say when you generate, you want to generate with punctuation rather than without. So just for illustration of how this works, of the kinds of OT marks you could have here. Okay, the morphology has stayed the same. Here in the rules, we've got a new thing. We've got something that's called root. This is now the root category, the new root category, and so far it only expands to S. The S still looks pretty much the same. There's been two changes to the S. to deal with some of the overgeneration with devoured, for example. You might have noticed that. It always came out as a past participle as well as tense past. What the sentence here does now at the VP level, it's saying, by the way, I would require that the VP have tense. Okay, so we're requiring at the top level here, we're requiring that there be tense from somewhere. And this gets rid of the past participle reading. Right, and then we have the optional period, and I've added an OT mark to it here, the punct OT mark, which was up here. It's a preference mark, and it says prefer having a full stop when you're generating. Okay. The VP rule has not been touched. It's the same as what you had before. Let me make sure that's the case. Looks like it. The NP rule, you should have done this in your NP rule. I've added the disjunct that allows for a pronoun. Okay, so we can have either full NP or we can have a pronoun. The AP rule is the same as before. The PP rule is the same as before. Okay, now let's look at the templates. These are all the same as we had before. I've added one template. It's the case template. It's a very simple template. It just says whatever the values put in here will be the value for case. Okay. And I've added in a pron template. You might have had a different type of template. This is what I did. It has 4 arguments so that you can take. The predicate, she, he, it, the number, the person, the pron type, pronoun, personal pronoun or possessive pronoun, for example, and then an end type saying what type of pronoun, what type of noun it is. So in this case, a pronoun. Okay, the lexicon has not changed much, except that we have added in now some pronouns. And I've added them in capital versions and non-capital versions because we don't have a proper morphology yet. Okay, then our determiners, and down here is the addition of the exclamation mark. And you can see I've also added some functional information here. So statement type, exclamation. This is a convention we adopted within Pargram saying what type of sentence it is, whether it's an exclamation or a declarative. Okay, so those are the changes that have been made to the grammar. Now, what we want to do is we want to be able to implement an imperative. We haven't gotten that yet. So let's see. Let's get our test file and see what we want to. I've prepared, or at least we should write down what we want to do. So this is the test flight 5, and I'm not going to be very ambitious. I just want to be able to parse this sentence here. We can test it to see what happens. Let's start an XLE process. Create the grammar, create parser, grammar 5.lfg. Okay, and now I'll just sort of hopefully try to parse this. And I cannot parse this because it says, first of all, it gives me a morphology window. That's a clue that it cannot build a tree for the sentence that I wanted to parse. And it also tells me here, chart unconnected because of unknown words, word possibly causing problem, implement. Now I've noticed in teaching these courses that people do not tend to read what XLE actually tells you, and then they're just stumped about what's going on. XLE actually gives you a lot of good hints. Some of the debugging problems are harder to do, but if you read what it's telling you and you pay attention to that, it's usually easy to find that. Okay, so we can start with this problem. We can say, okay, there's an unknown word implement. Let's fix that. Let's go to the grammar and add that in. I'll make this bigger as well. So we need to go to our lexicon section and add this in. It's a verb, so let's put it into the verbs. implement. It's a verb. It gets the morph code, this thing. Okay, what kind of verb is it? Let's think about it. It's a transitive verb. I implement something. So I can say at trans, call up that one, implement. Okay, what else? What other kinds of information do we need? Is it past? No, it's present tense. So we have a macro for that. So I can copy that over. Okay, and let's see, does it agree with its subject? Well, that's difficult to know because in implement it, we don't have a subject. So we can check, what does bear agar do? It looks to me implement is probably like devour. Okay, and we have bear agar there. Devour can be used as an imperative as well. Devour that. So let's just use that. And if we're not sure what bear agar does, we can go back and look at it. Go under LFG, rules, templates, lexicons, templates. There, bear agar is right up there, alphabetically the first. It says your subject number can be plural, or your subject number is not third person, and in that case it's singular. Okay, this is actually exactly what we need, because you plural or you singular, that's what it could be. So either it's plural, that's good, or it's third person, or it's not third person, so it could be second person and singular. And the simp rule should tell us whether it's second person. What I've already added in here is an OT mark saying you could decide on this or not. I've added an OT mark saying I prefer to have a singular imperative. One could do a corpus study to see whether that's true or not. But in case I don't have this in here, I will always get 2 readings. Okay, we can try to take that out later. Actually, I'll comment it out for now so that you can see the effect of it. Okay, comment that out. Okay, so we've added implement. That looks okay. So let's go back to our grammar. Restart XLE, create the parser, and then happily go and try again. Oops. Okay, and now XLE doesn't complain, but I still get this morphology tree, this morphology chart. That means that I have not been able to, the grammar cannot build a tree for these 2 sentences. Okay, so what do I need to do? Well, I need to build some rules to do that. So let's see, you can go back, look at the slides if you're doing this at home. Say, okay, what do I want? Well, in addition to S, I want to be able to also parse an simp. So either root can be either S or simp. And I need to spell that correctly, otherwise I'll have a problem. Okay, and then I need to introduce a rule for simp. So what will my rule be? Let's see if I remember the thing right. So I want an empty category that says up subj pred is equal to pro. Pro here means that we don't actually know what the pred, that it's a pronoun, it's referring to somebody, and whoever that's referring to will have to be determined by the semantics. Okay, and we also want up subj num person is equal to 2. Okay, so it should be a second person thing. And then it should be followed by a VP and by an exclamation mark, which is not optional. Okay, now I've written this rule. I would like to see whether I've done it correctly. I can use format, the integrated format thing in LFG mode, escape Q, and it formats it nicely and correctly for me, which means that I haven't made any mistakes, hopefully. Okay, so simp. So now I've got a rule. So now will it all work? We wonder. Let's go back, restart XLE. and create the parser with Control up arrow. And my test suite got lost. Let's go find that again. Okay, here it is. Cursor's on it. Escape, Control P. Oh, and here it goes. So I now have an imperative. So I have a root simp. Notice it doesn't expand to the empty category. It's invisible. I have a VP and an exclamation mark, so that looks good. Let's look at the F structure. I have implement, a subject and an object. The subject is a pro. We don't know who it is, but it's second person. The object is it, which is a personal pronoun, third person singular, and it has case accusative. Okay, so that looks very good. And the statement type is exclamation. One not nice thing, well, but maybe it's one can think about whether one wants to avoid it or not, is that one has two solutions. One in which the number is plural and the other in which the number is singular. Okay. Now if I don't want these two solutions, if I want to constrain the ambiguity, I can think about how to do that. And what I've done right now is decided to put it into this template, bare agar, and to say, I prefer a singular imperative, or I prefer singulars generally. This might not be the best way to do it, but for now we can test the effect. So restart, I did it in the wrong window again, restart the grammar, create the parser, get back my test file. Oh, wrong one. Let's make sure it's the right one, otherwise I'll get into trouble. Okay, and then let's try this again, escape, Control P. And now I just have one solution, okay? I've legislated against the other one. Like we saw last time, it's still there. I can click on this OT window, here it is, and I can ask for the unoptimal solution again. Okay, and that will be the plural one over here. So I've dealt with some grammar ambiguity in my grammar. It's not clear that this is the right way to go, but for now I say, okay, I don't always want two solutions for this. I will prefer the singular one. Right, so that concludes what we've done with imperatives. This will be exactly what I've done here. Not exactly what I've done, but part of your practical exercise will be to implement imperatives in your own grammar, or using this grammar 5 as an example. Okay. So now let's move back to the slides. So, oh, I've forgotten something. It's good I write myself some notes here. I also wanted to check on regeneration. So we have parsed this. And now, let me parse it again. And now I want to check on regeneration, what it does there. Commands generate from this F structure, just to make sure that things are working in both directions, and that's very nice. I'm getting exactly one reading back, and you can see it's been capitalized because the generation tokenizer, it's doing its job. It's saying at the beginning of sentences things need to be capitalized. Okay, and now we can really go back to the presentation. Okay, now we get on to the second part of the slides, and they deal with coordination. This is conceptually more difficult to deal with, so I'll try to go through this fairly slowly. Let's see. So coordination is examples like gorillas climb trees and eat bananas, the dog and the gorilla slept, things like that. There's a problem with coordination for grammar writing in that, or for the LFG formalism, in that every attribute is only supposed to have one value, okay? So in coordination, we actually have gorillas climb trees and eat bananas. We have a VP. And, well, so what is the value of the sentence? So what's going on here? You have climb trees and eat bananas. Both are objects, so do we then have two values for objects? Do we have two different predicates? What should we do? So what do you do with coordinated constituents? And the answer is, or the answer that has been put forward with an LFG, is to put them into a set. And what you get is the kind of rule that you've got here. So a VP expands into whatever VP expands to, and then there's a disjunct. So you'd have PPs, NPs, etc., all kinds of stuff in there. And then you have an additional disjunct. This is this. So this part is the normal VP. Then you have an additional disjunct which says or. You can have a VP conjoined. This is a conjunction that would take care of and, conjoined with another VP. And each of these VPs, I'm going to put them into a set. Okay, and then they will be part of this bag. And then I avoid the problem with having only one value. So the advantage of sets is that you can have multiple instances. We saw that with adjectives and adverbs and prepositional phrases. So no feature clash. The disadvantage is that these coordinated items are basically put into an unstructured type of, you can think of it as a bag of things. And you do not know which of these items came first unless you look back at the C structure. It is possible to look back at the C structure via the inverse projection. So there's a projection that goes from C structure to F structure called the phi projection. This is what the annotations instantiate. You can also look backwards from F structure to C structure by inverting that projection. It's mathematically well defined. Implementationally, it's a bit tricky to do. So you don't necessarily want to do it all the time, but it can become important to know which one came first for scope relations if you're trying to do semantic analysis. So the solution within XLE has been to register the linear order, or scope, you can think of it as scope, at F structure via this little notation here, this less than, and then S stands for scope. Okay, I'm just telling, this happens automatically in the rules that you will be programming. You don't need to do anything extra. I'll just show you the effect of this. In particular, I'm telling you because you will see solutions like this and you'll wonder about what that part is. So here's an F structure analysis of the dog ate a bone and slept. So what we have is actually at the very top level, we have a set. So we don't start out with one pred in the way you've been used to. What we have is two items within the set. This is one item labeled 5, and this is the second item labeled 14. We have one coordinate form and, so we know it's a sentence coordination. The first sentence, the dog ate a bone, is here, eat, dog, bone, subject, dog, object, bone, etc. Okay. The second sentence is here, dog, sleep, subject, dog, etc. What you can see here is that this dog is the same as that dog. This is what's called the information about the subject has been distributed across both conjuncts. Right? So the conjuncts are ate a bone, slept. And dog is the subject for both of these things. So what the grammar does, what XLE does, is takes the information about the dog, puts it into the first conjunct, but then also distributes it into the second conjunct. Okay, this is generally what you do with coordinations, that the information that should be in both you distribute again over all the conjuncts for which it's relevant. Okay, so that's what's happening here. And here's this little s that I was talking about, smaller than s. What this means is that eat preceded sleep linearly. Okay, and so this is something you can read off your F structure information quite easily. And in the grammars, it's been used to then as input for further semantic processing, for example. Okay, so let's move on. Coordination can happen at any level of C structure. For example, the gorillas peel and eat the bananas. What's the level of coordination here? It's the level of V, so not VP, but just verbs. So what you do the same thing. You say, okay, we have a rule for verbs and it does whatever it does. That's these 3 dots here. And then in addition to that, we have a disjunction, which consists of a verb being put into a set, the conjunction and or something like this, plus another verb. Okay. And it's basically every category that you have in a grammar can be coordinated. This is known as same category coordination. So I've got an example with peepees here. The gorillas eat the bananas in the cage and in the garden. So you would do PP coordination the same way that we've already seen. As a note, you can also coordinate categories that are not the same. There is some literature on this. This is much harder to do from a grammar engineering perspective. There's no good, very good solution out there. It can be done, but there's no absolutely good solution. And what I'm showing you here with coordination is really only the basics. We're only learning how to do very, very basic coordination. Languages differ in terms of how they do coordination. This is the very basic machinery that you can use to do coordination. You will want to build on top of this eventually. Okay, so how can we capture these generalizations? What generalizations? Well, that you can have same category coordination and that all of the rules look pretty much the same. You say, well, I have some kind of category, a conjunction, and another category. And then, of course, you could have more as well, but that makes the rules more complicated. So this is just the simple version. So how can we capture this generalization? Well, there's something called a regular expression macro in XLE. This gets put into the rules section, and here we've defined a regular expression macro as same category coordination. What it does, it takes a category as a variable, and then it says, okay, take this category, conjoin it with that same category. So this is same category coordination. For example, PPs. You have a disjunct in the PP rule that says do same category coordination. So then this PP gets substituted in here. So the effect would be PP conjoined PP, or you could have verb conjoined with a verb. Okay, so we can just use that one regular expression macro instead of going through all your rules and saying, okay, V conjoined with V, VP conjoined with V, P conjoined with P, etc. Just one rule. A very useful thing, these regular expression macros. You can use them for other problems as well. Okay, so we've gotten that far. Now a note on nominal coordination. Nominal coordination across languages tends to be special. Looking just as English, the number attribute typically needs to be plural, even when the individual set members are singular. So we have Mary likes bananas. This is singular agreement. But Mary and the gorilla, Mary is singular, the gorilla is singular, but it's no longer likes here. Likes is an ungrammatical version. It needs to be like. Mary and the gorilla like bananas. Okay, so like is doing plural agreement. The boys and girls like bananas, just like this plural one here. So somehow we need to be able to specify that. How do we do that? For one, we need to make sure that these the number information of Mary and the gorilla is not distributed across all conjuncts of the grammar, or Mary and the gorillas. This one would be singular, this one would be plural. We need to make sure that each of these can have their own specification. How do we do this? In the configuration section of the grammar, you have this thing called non-distributives. The non-distributives are specified right now as singular, as number and person, so you're not distributing these across all parts of the conjunct. These are exceptions, so the grammar knows don't try to distribute that information. It will try to distribute all the other information. Remember in the example that we had with the dog slept and ate a bone, that the subject was distributed across both conjuncts. So only if you're listed under non-distributive will you not be distributed across the conjuncts. In grammar 5.lfg, you will see num and person are specified as being non-distributives. So they are not distributed across everything. Okay, each conjunct can have its individual value. So that's the first step we need to do. Second step, so here, Mary and I like bananas. So number, person, okay, so plural, but also I is first person and Mary is third person. So they can each have their individual feature values. Okay, the second step we need to do is in nominal coordination. It works pretty much like we've seen before. You have a category, and this category followed by a conjunction, followed by another category. But in addition, what we're doing is we're saying the number needs to be plural. We're just specifying that here. Okay, and then we can go ahead and have NP coordination or N coordination via this regular expression macro. Okay, so we have two regular expression macros now, same category coordination for general categories, and then a special one for coordination within NPs, NP coord. Okay, then on top of that, there's a template here called NP conjunct, which is also called. And what this does is it does person resolution. This could be more or less complicated across languages. For English, this seems to work. What you do is you say if either conjunct is first person, the NP is. So what you're saying, so example, the boys and me. Okay. So then you say if one of the conjuncts, if Down's person is C, is constrained to be 1, then the whole conjunct is 1. If a conjunct is second person and the NP is not already first person, make it second person. So these are very complicated. So if then, this is, you can see how you can do very fairly complicated if then statements within XLE. So what's this saying? Down's person is constrained to be second. Okay. So if one of the conjuncts has second person and there is another first person, that's okay. Then you make it first person. Otherwise, assign second person. So if we don't have any first persons in there, then have it be second person. Okay? So you and the boys, that'll be second person. I'm not going to go through whether this is true or not for English, but this seems to be what you need to do for subject-verb agreement. Else, the elsewhere case is third person, so the boys and her. Otherwise, you assign third person. Okay? So you're making sure that the entire thing has the entire NP. What you're doing is that each of the individual conjuncts has their own person information, but the NP as a whole needs to have person information in order to do subject-verb agreement properly. Okay, with the number we already did, we just say it's plural. Now we need to understand what person it is, the entire NP, so that it can do subject-verb agreement. So the boys and me needs to agree with the verb. And the rules are if either conjunct is first person, make it first person. If a conjunct is second person and there's not a first person, make it second person. Elsewhere, make it third person. Okay, you can study this template at your leisure. It's a good example of how to do if-then statements within XLE. Right, okay, so now we can in principle do coordination already. We've got macros, we've got the regular expression macros, the S coord and the NP coord. Very useful way of stating generalizations across types of rules. But when you then go through your grammar and say, okay, now I'm going to make sure that each category can be coordinated, what you need to do is you need to go through each grammar rule and add a disjunct saying S coord or N coord, okay, for each of the rules. This can get very boring. You might have the time. If your grammar is small, it won't take that long. If your grammar is big, it'll take longer. But what we found that what was actually better to do is to do this whole thing via something called a meta rule macro. Okay, it's a special macro, meta rule macro. What this does is it looks exactly like a macro, but what it does, it actually applies across the entire grammar. So you specify it once. You never need to call it up in any of the rules. Every rule goes through this meta rule macro automatically. So it's a meta statement across the grammar. It says this is true of the entire grammar, of all the rules in the grammar. So you can't use it for many things, but coordination is one of the things you can use it for. Okay? So it never gets called up in any of the individual rules. It's a meta statement about the entire grammar, and each rule in the grammar will automatically include a look at the meta rule macro. So what does this look like? It takes 3 arguments. Cat, hang on, let me go through this. Okay, cat, base cat and RHS. Cat is the category in the left-hand side of the rule. Base cat is the same as category unless you are dealing with complex categories or different types of categories. Okay, and right-hand side is the right-hand side of the rule. These things all have underscores. This makes them instantiated variables, which means that they can only have one value. You can read about instantiated variables in the XLE documentation. Okay, so here's the meta rule macro, the way it is specified in the grammars. Cat, base cat, right-hand side. What you say is, okay, take the right-hand side of the rule. That's what it expands into. And here we have these empty categories again. What you do is you say, okay, the category is, if the category is in the set of N and P, invoke the NP coord regular expression macro. If it's not in this, if it's not in the set of N or NP, then do same category coordination. Okay, so all it does is it says, take that entire rule to the right-hand side of whatever, S, VP, take whatever's there and throw it into the NP coord regular expression macro or the S coord regular expression macro, depending on whether the category that we've got is in the set of N and NP or not. Okay, and you can expand this set as at will, depending on your treatment of nominal phrases. Okay, so to conclude this part, I'm going to show you briefly a demo so that you can see this all working. I've made a special grammar for it because it'll be part of your exercise to actually go through and get it to work for yourselves. So I'm going to call up the grammar coord just to show you how things are working and where all the parts are. Let's get rid of this, kill them all. Okay, and then do Emacs grammar coord. Let's make that bigger. Okay, let's look at this briefly. What have we got from the last time? Notice here the non-distributives, num and person, actually also the coord form. That's the and, that's the form of and or, etc. Everything else should be the same here. Like I said before, a number of the templates that you will need to get this all to work are in common templates.lfg. So then you will just have gotten this in here. Okay. So what we have is our normal rules. They have not changed. And then here is the meta rule macro. It's part of the rules section. And it calls up NP coord and S coord. NP coord and S coord are also here. Same category coordination, part of the rules. Okay. And they call up a bunch of things. NP coord calls up NP conjunct. That's the one I showed you with person resolution. That's here. Okay. And then all the other ones that are in there, inset, push P, etc. These templates are all part of the common templates. And you don't need to know exactly what they do. They are commented. But they're just making sure that we don't get too much ambiguity with coordination, because you can get a lot of ambiguity within coordination as well. Okay, so then this actually does not need to be there. That's part of the common templates. And then we have a little change down here, which is the conjunctions. So I've got and in here. Okay, with a template that's also part of the common templates. Right, so let's start the XLE. Create parser first. Parser grammar coord.lfg. And I've prepared a test file so that I won't make a mistake and think the grammar can parse something or when it can't actually. So let's look at that. So we saw this type of example already. Let's look at the dog sleeps, eats and sleeps, just for fun. So what we have is the dog here, and then eats and sleeps. Okay, this is same categorization on the VP level. Conj is and itself contributes, we can look at that, just coord form and. Okay, that's all it does. There is no NP coord S same category coordination. You don't see any of those, so you don't see any extra rules, right? What's happened is that the meta rule macro has said, oh, there's a VP and a VP. We can coordinate those two, and then has sent it to same category coordination. Let's look at the entire F structure of this. Right-click F structures. So what we have is what we saw before. We have two things in this set, two sentences. Eat, dog is eating is the subject, and it's being distributed across both sets, both members of the set, and here's the scope relation. Okay, now let's look at the gorilla and I ate. This time we have conj NP. This is been specialized so that it adds the number information. We can look at that. Show F structures. So we have coord form and now it's adding the information that is plural. Okay, because these things need to be plural. Let's look at the entire F structure. What we have is, oops. Okay, we have, this time we have the head of the sentence is eat. It takes the subject, but the subject is now a set. Okay, the subject consists of two parts, which is one of the gorilla and one I. And there's different person information, person 1 versus person 3. Okay, and there's a pron type here and not up there. The coord form is here. So you can see that person has not been distributed across both types of sets. The entire NP is plural and third person. Okay, this was done by the NP conjunct rule, this was done by and, this was done by the NP conjunct rule. And you can see that gorilla linearly precedes I. That's the information here. Okay, so that's the kind of stuff we can see. Now this is an example with two coordinations in one sentence. Two NP coordinations, the dog and the gorilla devoured a bone and a banana. You can get more complicated. Okay, a bone and bananas, and you can see there's different number information here. This is plural, this is singular, but it's all still working out. Where's the F structure here? So what we have is devour is the main predicate. It has a subject and an object. The subject is dog. The subject is dog and gorilla. It's a set, okay, and dog precedes gorilla. And the object is also a set, and we have bone and banana in here. And the number here differs, plural, singular, but the whole NP is plural. Okay, so that is how that works. There was one more thing I wanted to show you. So far we've always been parsing entire sentences. But you could also, for debugging purposes, you could decide that you only want to parse, for example, an NP. So, for example, the gorilla and I, curly bracket. So what you do is you say, I don't want the entire grammar rule set here. I just want to parse this as an NP, not as a sentence, just as an NP. Then what you can do is you could put NP colon in front and parse it like this. And then it'll just give you the NP. Okay? The gorilla and I. It'll just give you that part. If you tried that without it, it would give you an ungrammatical structure. The gorilla and I, just without the NP on there, it'll say can't find a tree. But if you specify that you just want this as an NP, then that'll work. Hang on. Yeah, here you go. Okay, and you can do that for various things. You could also try to do something like parse VP ate a bone. and that'll parse the VP for you. Okay, it'll give you that, but it won't give you any F structures, and you can try to see why not. And the reason why not is because it doesn't have a subject. Okay, so in this case, if it's a VP and there's information outstanding elsewhere, you will get a tree that you can look at. This is useful sometimes. But you won't get an F structure because there's information outstanding. It's incomplete, for example. Okay, so now let's go back. We're basically done now. We're done with session 6 now. The practical work you will do is detailed in exercise 6, and you will practice with imperatives. You will basically implement what I showed you to implement, with a few more examples, of course, using empty categories. You will implement coordination. This essentially actually only involves copying and pasting from the starter grammar, but involves copying and pasting several different things from several different parts. So I anticipate that this will take you quite a bit of time and involve quite a bit of debugging. And then in addition, you should implement proper nouns. You might want to do that before you start implementing coordination. That's the easier task, and you should do that using the strategy that I talked about last time with respect to pronouns, the overall strategy. Okay, so that concludes this session.